Good evening, students. Today we are going to discuss about sound, one of the topic in diploma as well as intermediate. Let's start. What is sound? Sound means energy. Sound is one of the form of energy which stimulates our sense of hearing. If anything is making sound, that means it has some energy. If we take sound, the particles of the medium vibrates. Here, each particle of the wave moves parallel. Here, particles move. Sound will be in the form of waves. Here, particles moves like this. Here, each particle will be adjacent to each other. We take sound is one of the forms of energy. Which stimulates our sense of hearing. Students, take down the notes. It will also be helpful for your exams. If we see, everything makes sound, right? If we see outside, automobiles or vehicles, transportation, everything will happens by the sound. Then everything makes sound waves. Yeah, audible range of sound for a human being is 20 Hz to 20,000 Hz. Human audible range. If it is less than 20 Hz, called infrasonics. If it is greater than 20,000 Hz, it is called ultrasonics. I have already told you, sound will be in the form of waves. How many types of waves we have? Longitudinal wave as well as transverse wave. Here, sound is which type of wave? It is a longitudinal wave. Longitudinal wave means what? Longitudinal wave. The wave motion in which particles of medium vibrate in a direction parallel to direction of propagation of wave. Here longitudinal wave means the particles of the medium vibrate parallel to the propagation of the wave. Here if you take sound wave in air, example is sound wave in air. Here sound waves travel parallel to each other. These are the examples for longitudinal waves. Here if you see particles of the wave also travels parallel to the wave. This is a longitudinal wave. If you take transverse wave, here the wave motion in which particles of medium vibrate perpendicular to the direction of propagation of wave. Example, water wave. Water wave. Here if you observe, here each particle will move perpendicular to the propagation of the wave. Means the particle motion will be like this. Sound waves comes under longitudinal waves. Okay. Make a note. If you observe musical sound, what is musical sound? The sound which is pleasant to hear is called musical sound. Means some of the sounds are irritating, some are not eco-friendly. We feel irritated with the listening of those sounds. If you listen music, we feel relaxed. Means it is pleasant. So sound which is pleasant is called musical sound. Because here if you see wave pulses will be in regular mode. They follow one after another. Sound from musical instrument like guitars and sitars, these also comes under musical sound. If you see noise, that is unpleasant. If you listen to any kind of noise like vehicles or automobiles, we feel irritating, which we don't like, because the wave pulses are not regular. They will not have a particular interval. Means they follow undefinite paths. High, low, and these all. We see amplitude. The amplitude will be like this, increasing, decreasing, and increasing, again decreasing, increasing will be. This unpleasant. Changes with time. If you see examples for these, sound produced by crackers, these also unpleasant. This is also comes under noise. You observe noise pollution. Noise pollution means which is more than human audible range and which also interferes with human communication, comfort and health. This all comes under noise pollution. The loudness of sound depends on amplitude of sound. Greater the amplitude, louder will be the sound produced. If amplitude increases, the sound which we hear will also increase. SI units. SI unit for noise is decibels. This is indicated with dB. What are the causes of noise pollution? The noise produced by thunders. During thunders, we receive lot of noise. That is also comes under cause. And public gatherings. If you see public gatherings, we hear lot of noise from people. This also creates a lot of noise. Noise from musical instrument during functions. They play a lot of sound. During the decks and all, will produce lot of sound. Loudspeakers and from horns, traffics on road, and some industrial factories, machinery. While producing machinery also, they makes lot of sound. Yeah. Plus crushing of explosives, they also produce lot of sounds. What are the effects? The effects of noise pollution comes under health disorders, comfort, and efficiency of human being. Causes mental disorders. It also causes heart, liver, and kidney problems. What is beats? If you produce a sound by taking two frequencies or two tuning forks, the periodic increase and decrease of loudness when two sounds interfere nearly equal frequencies interfere with each other. Means periodic increase and decrease of loudness of sound when two equal frequencies interferes. Increase, decrease, these all comes under beats. These are beats. The frequency of first wave will be reduced from second wave, that is n value. Total frequency. Beats are used in tuning musical instruments, and these all you observe. In exam, if they ask question like this, two notes of frequencies, 50 Hz and 500 Hz and 200 Hz are sounded together simultaneously. Find the number of beats produced per second. That is n1 equal to 500 Hz. We need to take n2 equal to 200 Hz. We want number of beats produced per second, n equal to n1 minus n2. So we can 500 minus 200 equal to 300. Number of beats produced per second is 300. You take like this. Let's take second question. Two tuning forks produce beats. Two tuning forks producing beats of produce 5 beats per second when sounded together. The frequency of one tuning fork is 200 Hz. Other one with wax, loaded with wax. The beat stops. Find the frequency of the second tuning fork. Here the frequency of second tuning fork is n. Number of beats frequency of second tuning fork equal to n. Number of beats produced. What is that? Number of beats produced equal to 5. 5 per second. The value of n value is 200 plus 5 equal to 205. It is loaded with wax. So if we subtract, that is 195. 195 Hz. The frequency of second tuning fork is 205. When it is loaded with wax, its frequency decreases and equals to the frequency of first tuning fork. So here the beat stops. Let's learn about reverberation. What is reverberation? Persistence of audible sound even after the source has stopped. Means if you see in a concert halls or movie theaters, sometimes if what we have spoken is already completed, but it persists in the hall for some time. You observe, that is due to reverberation technique. Means here it touches the walls Again, here, if you see, touches the walls, again reflects back, and again it will reflect, again it will be heard. This is the process by which it repeats again and again. Distance traveled by the sound through different paths is different. So, time taken by the sound to reach the observer through different paths will be different. So, each reflected path will reach the observer once. So, it will have different directions. At different times, it will be heard. We have the formula to find out the reverberation. 0.165 V by AS. T is the reverberation time, V is the volume of the hall, A is the absorption coefficient of a surface, S is surface area of the surface. Absorb sound. Echo. Zero 0.165 V by summation AS. Echo means the sound that is repeated once after the original sound due to large obstacle. When it touches wall or anything, it will be reflected back. That is echo. But the sound that is repeated once after the original sound due to reflection at large obstacle is called echo. When it touches the large obstacle, it reflects back. Once it travels from the source, it touches the, when it touches the obstacle, it reflects back to the observer. Means the path is not straight. It is reflection. Due to reflection, after touching the obstacle, it is coming back. That is known as reflection. This is echo. Echo will be heard when woodcutter hits the tree with axe. Means if the woodcutter cuts the tree, what will happen? What will happen? If he hits this one, the sound will be produced. And due to the obstacle, what will happen? It will reflect back from the source. Here D is the distance of the obstacle from the observer. V is the velocity of sound. T be the time to hear the echo. So small d equal to 2d by 2 equal to mu into t by 2. If the velocity of sound is 30 degrees centigrade, is 348, and minimum interval velocity of sound nu at 30 degrees centigrade is 348 meter second inverse. Minimum time interval t equal to 0.1. Want to find the distance from source to observer. 348 into 0.1 by 2. That's the formula, no? Substitute here. So if we cancel this one, how much? We'll get 17.4 meters. Conditions for good auditorium. The loudness of sound should be uniform in the entire hall. The sound should be no echo in the hall. The outside noise should not enter into the hall. The sound should not be any airborne noise. There should not be any noise due to non-structural elements. The loudness of sound should be uniform. Means if it touches the auditorium, the loudness which is heard by person who is sitting here, it should be reflected with equal amplitudes of sound. Each person should hear with equal amplitudes. There should not be any echo. Means the original sound only should be heard by the observer. There should not be any reflection. Outside noise should not enter into the hall. Means the hall should be packed. Means the walls and everything should be a packed way. That means no other noise enters into the hall. Bulletproof glasses and all should be maintained. Soundproof glasses. There should not be no resonance. Means repetition of sound should not be there in that auditorium. Means these are conditions for good auditorium. Okay, students, this is the main concept in sound. If you understood this, you can easily write in your own words in diploma exam or any other exams which you will be having this sound concept. So students, continue this. Keep learning from my channel, that is thank you all.